This is day 4 of 90-day challenge. Today we are going to do trapping rainwater question. It is of difficulty hard. We are given an array ARR with non-negative integers representing the height of blocks. If the width of each block is 1, compute how much water can be trapped between the blocks. So here if you see the example, the question is that we are giving the height of the building, which is represented by gray here, and we have to calculate how much ever water is getting collected between the buildings. So let me just come here to make you guys understand. Now if you see the buildings here, this is the one building, this is one building, this is one building, this is one building. I think it is pretty clear that the water cannot go beyond this level, otherwise it will overflow from here. Similar is the case here, that it will overflow from here. Similar is the case here, it cannot go up till here, otherwise it will flow in either of the directions. So how will we approach this question is, we'll calculate water for each and every building. For this building, for example, the water would be 0, for this it would be 3, for this it would be 2 units, again it would be 3 for this, again 2 units here. So the total water is gonna come as 10. This is the higher level perspective of it. But what approach are we going to use for solving this question? That is the main part. So the approach that we are going to use here is, for each element we are going to find maximum to the left and maximum to the right, not next greater element. We'll be finding whatever is maximum in the given array. So for example, if the array is just 3, the maximum towards the left would also be 3, and maximum towards right, what would that be? I mean for the element 3, not if the element array just is 3. For the element 3, what would be the next largest element? Not next largest, but the largest element towards the right, and it would be 4. So this would be coming as 4. Okay, similarly for 0, again it is 3, and again it is 4. For even 1, it is 3 and 4. For 0, again 3, 4. For 4, it would be 4 and 4, as there is no greater element towards the left or right. This is the largest element in the array. For 0, it would be again 4 towards the left, 2 towards the right. For 2, 4 and 2. But how are we getting these maximum values in terms of formula? So if you see, we are trying to compare these two, and on the basis of comparison of these two, we are finding the value this. See, again they are comparing these two. Whatever is maximum of these two is coming here. Again this is compared by 0. The maximum value is 3, so 3 came here. Now 3 is gonna get compared by 4. Now 4, because 4 is the largest value, hence we are getting 4 here. Again we are gonna have comparison between these two, again between these two, and whatever is largest is gonna come here. For MR, it is the other way around. For, let me change the color. Let me remove these so that it is easier. It would be 2 for the last one. Then we are going to compare with each element. 2 is going to get compared with 0. Maximum is 2, so maximum comes here. 2 is going to compare with 4. 4 is maximum, so 4 is going to come here. Then 4 is going to get compared with 0, hence 4 here. Then 4 is going to get compared with 1, hence 4. 4 is going to get compared by 0, so 4. 4 is going to get compared by 3, so 4. Hence So we are getting this and this as the MR and M left, which is maximum element towards the left and maximum element towards the right. It does not matter if it is the next greater, but it needs to be the largest in the array. And with that, if we use this formula, see, if you see here, how much water is getting trapped, it totally depends on whatever is the minimum height of these two, right? So minimum of maximum of left and maximum of right minus the current element. So for 3, if you see, the maximum L is 3 and maximum R is 4. So whatever is minimum of these two, in our case it would be 3 minus the current element is also 3. So the water trapped on this building would be 0. For next element, if you see, we have ML as 3 and MR as 4. So minimum of 3 and 4 is 3 minus the current element is 0 now. So the water trapped is coming as 3. For next, it would be 3 and 4. Again 3. The element is 1 now. So the water trap would be 2. Again 3 minus 0, hence 3. For 4, if you see, 4 and 4 is there, so 4 minus 4 would be 0, hence no water trapped. For the next element, it's 4. Okay, I'm sorry, I do not have mentioned it here. I think I've removed it. It will be 4 only. So 4 minus 2 is 2. That is the amount of water trapped. For 2, it will minus 2 minus 2, so it's 0. If we add all these, let me change the color. If I add this and these, I'm gonna get 10, which is our required answers. So this is the approach that we're gonna use today. And let me just quickly code now. So we'll be needing two arrays. One would be maximum towards the left. It would be new int arr dot length int mr is equals to new int arr dot length. Now one thing to note here is ml of 0 would be equal to ml of 0 would be equals to arr of 0 and mr of n minus 1. Let me just take n as arr dot length is equals to arr of n minus 1. Once this is done, let me just take I is equals to 0, I less than n, I plus plus. Now for m, L of I, it would be math dot max of arr of I minus 1 comma ml I minus 1. See, I'm starting it with 1. So what I am trying to do here is whatever I showed you here, right, that ml of I, this we know is already equal. Let me just quickly write it here. ml, this is 3, this is already 3, the next element would be this. So what I'm trying to do is array of I plus 1. It should be I plus 1 because we are comparing these two, no? So area of I plus 1 and ml of I. Whatever is greater, we should get. Now I think it is correct. I'll explain you guys again. How is it coming? So array of I, if we are starting I by 1, so array of I, and the comparison should be between array of I and ml of I minus 1. This is correct now. See, whenever you're not able to understand how is this gonna work, just mention I here as 0 and then 1. So if we are starting our loop by 1, I is equals to 1, then we're going to compare ARR of I with ML of I minus 1, and that will give you ML of I. See, ML of I is equals to mat.max of these two. Okay, once this is done, we'll take I is equals to n minus 1, I greater than is equals to 0, I plus plus. So MR of I is equals to math dot max. Now it would be ARR of I, comma MR of I plus 1. If you're not able to understand this, let me just open this again. So for MR, we're starting from the end. The array would be something like 3, 0, then 1, then again 0, then 4, then 0, then 2. So before starting only we have said that this is going to be same. Now we are starting from here. So we are going to have I is here, okay. So our comparison would be ARR of I and MR of I plus 1. That is what I have also written here. Once this is done, what we'll have to do is for int I is equals to 0, I less than n, I plus plus, take int water is equals to 0. Now water plus is equals to man dot min of ml of I, comma mr of I, and we have to subtract ARR of I from this, and this should give us our answer, and we have to just return water here, and I think this is the code and this should run perfectly fine. Let me just compile and run. See, I'm getting a compilation error because I've done this wrong. Now it should work. It already worked. Let me just submit now, and this has passed. The only catch here is that to know that we have to calculate maximum towards the left and maximum towards the right for the entire array for it to work. And we have to also make sure that we are calculating ML and MR properly. If we are doing that properly, then in that case it is very simple question. The only part that is tricky was to understand that we do not need the next greater element, but instead we need the maximum elements toward the left and maximum elements towards the right. If you're able to figure that out with question, then this question is nothing but a very easier question. One thing to note here is, although this rainwater trapping area of histogram and the question that we did last day, which was container water element, they all look similar, yet they are very different. The approach to solve all three of them is very different. For area of histogram, we were doing next greater towards the right and next greater towards the left. Let me just open it. My bad, we're doing next greater towards the next smaller towards the left, and next smaller towards the right. See, you will be needing next smaller here and next smaller here to understand till what width will you be expanding. So the largest area of histogram is about next smaller towards the left, next smaller towards the right. Container water is about two pointer theorem, because there you'll have to just shrink your water. You'll have to shrink your low and high to just find out how much maximum water can it support. And today the trapping water is about finding the maximum towards the left and towards the right, and then attempting the question to find what amount of water is present on top of each building. Thank you so much. Please like and subscribe the video. We'll be doing more questions like these going forward, and I'll try to attempt one more question today, and I'll upload it if I'm able to attempt. Thank you so much. Like and subscribe, and let's just do it together.